Thank you, Neil. Thanks. I'm very excited to be here. It's out of my comfort zone, talking to so many people, but it's great. As Prof. Gay LaRue would say, esteemed colleagues. Yeah, my wife's got a bit of a sense of humor, but I live outside Kenton, about 2 k's out of town, and we live on a small holding. We've got chickens and we've got other things happening on the property. It's not what you'd expect when you... I do have a secretary and a bit of an admin system as well, and we do kind of keep it a little bit together short. But it's built. I joked to somebody the other day. I said the birds in my office are incompetent, and I put it on my Facebook. And then Les walked in the next morning, and I had to apologize to her. So I didn't mean anything by that, Les. I was just trying to be funny. You know, it's not in any way a reflection. My story goes back. I grew up in Jeffreys. This is one of John Rushmere's houses in Jeffreys Bay, and I think that was really the beginning for me of architecture. Suddenly I saw a house could be more than the 4 walls we're used to. And I think at Varsity, at UPE, you talked about the Dani Tehran era that we come from. And John Smallwood and I used to have these debates, because as a student there, I was very stuck in the materials and methods side of things. So I struck a note with John. We had these chats, and I used to whine about the design approach, which was all reach for the skies, don't worry about what's going to hold it up there, expand your mind. I had this business idea. I was going to build log cabins. In fact, I built my first one at 171 Prospect Road, sort of a mountain log cabin, complete with mezzanine and log fire, the works, based on this system. What I came up with was to use no fines concrete in conjunction with timber like a composite material. Now, the thing with no fines concrete, as you know, it's without the sand, it's just the cement and the stone. It's got no capillary action. It's got no capacity to hold moisture. Plus, it's aerated. And thirdly, a very important aspect is the hydrostatic pressure in casting is very, very low. And you can cast full height in your walls. And you can do these like quite prefab. You can develop kits which are fairly lightweight. You've got your concrete core and your outer logs. And then on the corners, we do like this notching, this mock notch effect. And it's very effective. It's seamless. We all like to play with materials. We'd all like to do something unconventional, perhaps. I built a garage at my home. This was about 15 years ago. I don't know if you can see the bales of straw here. It's quite a funny story. I ordered the bales of straw from a local farmer, and I thought we were talking about those bricks. I didn't realize it was a bucky-sized bale. So I ordered like 12 bales or something, and I only needed 1.5 to build my... So we make this lattice, and you can see the section through the wall here. And then we put chicken mesh both sides, stuff it with straw, ram it with straw, and actually tie it with wire. And there you can see the process of stuffing the building, and then we get rid of the bulges by like a pin cushion, like a cushion. You know, when you stick a piece of string through and the buttons on the end and you pull it together. I don't know if you can see, but that's what it looks like today, 15 years later. And there was a learning curve. There were mistakes, but I tell you, it's amazing what you can do. This building cost me next to nothing. The guy who charged all the labor combined was 10,000 Rand, perhaps. The materials were negligible. The only thing that cost money was the roof. I used a clip-lock roof sheeting, which... Sort of coming back to the timber thing, and if there's any takeaway this morning, and if there's anything I was trying to prove, it would be about wood, and I want to do that very briefly. But the value of timber in construction and why we don't use it enough. Because I've built... my philosophy was timber frame, as far as possible prefabrication. That's been my whole drive all the way through. I've built a fair number of timber houses. I have found, for me in Kenton, we talk about critical mass. It applies to construction as well. What works for me in Kenton is there's a design and build thing. So our clients would know kind of what they're getting. We can sell what we do based on what we've done before. I'm going back to the composite timber concrete thing again. And I'm not here to preach composite timber concrete, only timber. But it's just one application of timber, which I think is interesting and novel. That beam is let's use this beam here, a nice enough example. Let's say I was going to retrofit a beam over there to do that workload that beam is doing. And I'm going to use an I-beam, a steel I-beam. I could use a timber beam, a timber laminated beam. Now, what's interesting is the I-beam and the timber beam with a spec sufficient to do the same work is going to weigh about the same. It's surprising, that fact. One wouldn't think it. Obviously, the timber is much more robust. It's got a much bigger cross-section, but it's going to weigh about the same as the steel I-beam. Very interesting. Here's the thing, though. The dry weight of timber, the dry weight, is about 50% carbon. Almost 50% of that weight is actually carbon. Now, you know the greenhouse gas carbon dioxide. Carbon dioxide is 2 parts oxygen, 1 part carbon. The atomic mass of carbon is 12. The atomic mass of oxygen is 14. So if you put 1 part and 2 parts, you get a mass of 40. So CO2 is 40. When a tree is growing, it takes out of the atmosphere the carbon and it releases the oxygen. So it takes 12 into its own mass, and that represents nearly 50% of its final mass as a dry weight. So if I'm using a ton of timber, I'm taking out of the atmosphere roughly 2.5, is that right? About 2.5 tons of CO2. Here's the thing, if I'm going to use an I-beam, it's in reverse. It's the exact opposite. I'm actually putting into the atmosphere CO2 to the same extent that I would have been taking it out had I used wood. So timber is being used in composite and in other ways to produce any kind of building you can think of around in parts of the world. We've got to be a little bit eccentric in the Eastern Cape to use and to work with timber, to accept timber in that way. So we obviously, okay, so here's our prefab panels again. We stack them upside down, cross them upside down in stacks, so don't take up too much room. There's a gantry just above there which can lift and move them around. And there it is being packed out on the deck. I have to talk about the box beams. I talked about the timber beam. I was talking about a laminated solid timber beam. Now I'm talking about a box beam. Economy of a box beam as opposed to, say, a land beam is a wonderful thing. So the only catch with a box beam, of course, is the way you make it. There are some, obviously, tricks to making it. But we use box beams all over, underneath heavy decks. This whole roof, even the garage door, is a box beam. I'm going back now. This is another composite structure. This is actually my father-in-law's lounge, which is directly below my office, by the way. I've worked on top of that slab for the last 15 years at least, so it's no creep. Okay, this is the detail I want to show you. So, okay, I need to go back because I don't want to dwell too much on technicalities, but this is important. This perhaps is a bit clearer from where you're sitting. You see, there's these are in fact our Eskom poles which were lying on the side of the road, and I made arrangements with Eskom, and I managed to buy a few. So basically, you've got no, really, I did pay for them. It's important in this day and age, I'll tell you. Okay, so that's a dropper. That is your pole. This is the pole. Okay, this pole over here is your bearer. Those are your beams, you could call them, going across. And then the droppers are, it's like temporary or permanent shuttering. That is Hessian, which we've kind of upholstered the thing. I don't know if you can see, this is a nice example where we've used, I mustn't get too technical because I don't think we are really here for that reason. But okay, so we put a membrane over here. I start with Hessian over there. We staple it onto these runners here. I don't know if you can see the Eskom pole down there. Okay, that represents your bearer. I'm looking at it from the top. That's the wall that we're keying it into. So the membrane comes up and down and it ends there. Then we put a polyprop membrane. Polyprop membrane costs next to nothing, as opposed to when you normally do a shutter for a concrete slab. Of course, you use plywood, which is 400 Rand a sheet. Probably about 120 Rand a square meter. Polyprop is about 8 Rand a square meter. And it's strong enough, if you've got, say, supports about 400 apart, you can use a polyprop membrane and pour concrete over that. You've got your wire mesh, so a wheelbarrow can run over it without puncturing the polyprop membrane. So there we go. We tuck it in. We pour concrete. This is a detail that Andre Malherbe did for me, by the way. And it was surprising. We were worried. We were interested in the shear connectors because obviously, how do you connect timber to concrete? That's the big question. It's obviously a shear issue, and shear is at its worst or maximum at the ends of any beam. So we calculated these notches and coach screws, and it's just like, it's surprising how easily you can connect timber to concrete. And then the big question is, what about expansion and contraction with timber? Now, the fact is timber is out of control across the grain, moisture or thermal, the way that it moves. But in the length of the timber, it's as stable as granite. You can put timber next to concrete, next to steel, you can fasten them together and you're not going to have a problem. I can't cast timber into concrete because it's going to swell and perhaps create kind of a spalding or a rotting, because the timber has to be aerated. So they are side by side, the two elements, but they're composite. The next thing is, okay, there's foam concrete. This is another application. What we did was we made these beams, by the way, radically over-engineered. But in any case, it was the first time I did that particular application. It's a lightweight prefab beam. And then we cast it into these, where you cast concrete. But if you look here, if you can see the black plastic there, we wrapped the whole beam in 250 micron plastic and then put our mesh on. And then we cast it in foam concrete, where the concrete foam is about 50 mil thick all the way around the beam. We got it a bit wrong because in places the mix wasn't quite right. And also, I was erring on the lightweight side. I should have been more conscientious about the strength or the hardness of it. So it was hard enough, but barely. There the beams are. Or some of them. We've got these notches because this, you'll see now the plan. You see these corners here. They are they fit together. But if I just go back, it's only got one bolt because we've got a steel plate there and we welded it onto supporting I-beams. So there's a cantilever supporting I-beam coming away from the building on a column or whatever, and the beam gets bolted first and then welded onto that. And these flanges here are to receive horizontally, to receive your lipped channel joists, onto which we put IBR sheeting, and then we put a concrete and mesh topping. So basically, we should be, my brother-in-law is an architect, looked at this when we were building and said, I would just use concrete. and he was right. So it was an old house, not an old house, but an ugly faced brick house, sorry, no offense, but that old rock, anyway, I shouldn't have said that. Okay, so there you see the I-beams, structural support. And then we put on our lip channels and decked it, and for all intents and purposes, it's, I think, the equivalent of if it were reinforced concrete. This is a, excuse me, this house I did, I built this, well, we built this ourselves. Those beams are actually marine ply with a timber core. So it's a timber frame structure. Very cool corners. That was an absolute triumph. The corners are mitered, but the crane picks them up and then they drop in. But I've got like a male-female connection with like a taper system in it with a big eye receiving, but then it tapers down so it comes to like a keyhole effect. So it drops in and it closes and it tightens and it locks into place. Pulls itself together. So the corner was this was one of those, you know, when some days the birds sing. It was prefabrication, came to site, went up, and wow, it was everything we expected. And I actually made money on it. I actually made a profit. We're busy with this right now. This is a rim flow pool on the front, a beautiful view of the ocean. Again, beams prefabricated, dropped into place like that. I've done a fair number of them. This is a project we're busy with now. This is another one. This photograph was actually taken this week, on Monday, I think. So we were just lifting up these 550 kilogram I-beams into place, steel frame. And I'm heartbroken. That's not even, I mean, now we get a Cape Town company to come in and supply and build. It's all very nice. It's all very convenient. But so expensive and so disappointing from an environmental point of view. And this is my project. We've just broken ground with it. It was designed as steel frame. And for some reason, steel frame is still much more acceptable to the markets, it seems, than timber. And yet, it's on the beach. I mean, metal rusts, you know. So you've got to use AZ200 in your metal framing. And the cost is, bricks have a big future. Yeah, just to show that I can build and design reinforced concrete buildings. And this is my last slide. And I just want to talk about that. Back to the chickens. Sean will know this very well. This was a first-year project. I'm sure most of you would have remembered that in first year. We had to build a creature design make a piece from paper, make a single element. I think it expresses what I'm saying as a designer, where I like to take John Smallwood. I like to start with a material and I like to start with a pile of bricks and think about what best can I do? When I was a kid, I had Lego, lots of Lego. And it wouldn't be, what does the instructions say? I wasn't interested in that. I was, what is the ultimate thing I can build with that pile of Lego? And that's how I feel about architecture, is it's a result of where you started. If I was in the North Pole and I only had ice, I would still be a builder.